Coming up on Catalyst, the science behind science fiction films. And how safe is eating a can of tuna? Catalyst investigates mercury hotspots and fish you should avoid eating.
It's alive.
What has this science fiction classic done for the image of science?
It's alive!
Gosh, talk about a mad scientist archetype. You know, this guy is working in his secret lair, doing horrible, unethical things.
Indeed, Frankenstein's become the archetypal story, invoked whenever scientists are seen to be meddling with nature. So, we thought we'd ask the question, what's science fiction ever done for us? When it comes to the science, how accurate is it? And in terms of image, is sci-fi ultimately friend or foe of science? Let's start with one of the classics, Star Trek.
To boldly go where no man has gone before.
The stories are set centuries in advance, so there's plenty of room for speculation. A warp drive, for example, that manages faster than light travel, can't yet be ruled out by the laws of physics. But is a matter transporter possible? In all the Star Trek stories, it reads a person atom by atom, then rebuilds them somewhere else. We asked physicist and writer, Professor Lawrence Krauss.
Alas, unfortunately, the transporter, I would argue, is impossible. It's because of quantum mechanics that I don't think you'll be able to transport people now or ever. Because, in fact, the Heisenberg uncertainty principle tells us that I can't explore you down to the atomic level and make an exact reproduction of you.
German physicist Werner Heisenberg showed there's a fuzziness at the atomic level, making it difficult to predict the behaviour of particles. Now, the Star Trek makers, like Michael Okuda, knew this was a problem.
So on the show, if you watch it, there's Heisenberg compensators. And when Michael Okuda was asked, how do they work? He said, very well, thank you.
Some movies go to great trouble to get the science right. I caught up with astrophysicist Katie Mack to hear about one of her favourites. The Martian, starring Matt Damon.
Seeing the Martian landscape was amazing, and all of the rockets and everything. I got a huge kick out of it.
The technology was quite realistic. The creators must have spent some time studying NASA. And even Mars's moons were the right wonky shape.
The Martian is all about problem solving. You're in this difficult situation, you have to figure out how to survive. And I thought that was done pretty well.
I found the scenery particularly realistic. The landscapes were just as you'd imagine them from NASA's pictures. Really made me feel like I was there.
And they do have dust devils on Mars.
They do,
That's
yeah.
good to see.
Yeah. I got really excited when I saw. I was taking notes in the cinema when I saw this. Yeah, because I was going to write something about it, and I wrote down dust devils.
Martian dust devils can be 50 times wider than ours and 10 times higher. But not all was realistic.
Yeah, so that dust storm, to me, way too strong.
There wouldn't be things flying through the air like that. I wouldn't be blowing things over.
That's because on Mars, the winds may be 100 kilometres an hour, but the atmosphere's thin. The pressure is less than 1% of Earth's, so the winds can't pack much punch. But I guess they needed something to start the movie dramatically. My first experience of a movie that was so scientifically accurate, even the experts in the field were impressed, was when I was doing a story on flu pandemics. And this was the movie Contagion. A flu pandemic sweeps the world, kills hundreds of millions of us. Civilization falls apart. It's a Hollywood doomsday scenario. What would a scientist make of it?
It's very realistic, yet genuinely scientifically sound.
Respiratory spread viruses are the worst nightmare.
In some ways, it's a documentary. It's actually documenting, guys, this is round the corner.
Yeah, I love that film. That's one of the movies that I think does the best job of depicting how scientists actually are. They just really were interested in the problem, they were passionate about their work, and the way that they talked and the way that they acted just seemed very realistic to me. And so I love seeing that on screen because it's so rare.
The movie Interstellar took the science to an extreme by having this man as one of the executive producers. Black hole expert, indeed physics guru, Professor Kip Thorne. Kip even wrote a book explaining the physics of the movie. Central to Interstellar is a supermassive black hole. These beasts can slow time. It's because of their immense gravity. Indeed, gravity slows time even when it's only slightly stronger, like it is at sea level on Earth compared to high up.
On the surface of the Earth, time flows more slowly than at high altitude by 1 second in a century, 1 second out of 100 years. That's a tiny, tiny slowing of time, but that means if you live on the surface of the Earth, you move to the future faster, and that has been tested experimentally.
A black hole's extreme gravity amplifies the effect unimaginably.
And so if you get very close to a black hole, you could linger there for an hour and you could go as far into the future as you might want if you can manage to get down there that close to the black hole and then get back out.
Ah, look at that.
Yeah, that's
great.
The black hole graphics were particularly stunning.
The imagery of the black hole was based on real equations, and they got some papers out of that, so that was really neat.
So what you see is what a camera actually would see if it were up near the black hole or the wormhole. It's marvelous. It's the first time it's ever been attempted in a Hollywood movie.
Although Katie's not entirely happy with Guru Kip's film.
There was some aspects of it that I wasn't. I didn't
Oh,
like so
come on,
much.
tell me, yeah. No offense to Kip, of course.
Sure. You know, I mean, as an astrophysicist, you know, I actually study what's out there. And there are things in that film that we really wouldn't expect to find. There was a planet very close to a black hole, without giving too much away. I think that's very unlikely.
The problem is, black holes are known for eating everything that comes their way, including planets. But maybe that's being pedantic. After all, Kip's primary goal was inspiration. And that's an important point. It seems good science fiction does inspire scientists. Take the movie Gravity.
I mean, I don't really have a desire to go into space and be an astronaut, but I could sort of see the appeal of it from the movie.
It was beautiful. I mean, I saw it in IMAX 3D twice, just because it was such a beautiful, immersive experience. You know, it looked like being really in space. And I've heard interviews of astronauts who said that, yeah, that's what it looked like on the space station. That's what it looks like on a spacewalk. It did really spark that in me, that desire to go out there and explore.
But could science fiction sometimes be bad for science? Because it falsely raises public expectations.
As a kid, I was inspired by visions of the future like this. I still don't have my flying car yet.
Actually, inventors have been working on them, probably because they were inspired too. But flying cars do seem a little impractical. And what happened to those jetpacks science fiction promised in the 60s?
You know, I was reading up on jetpacks a few weeks ago, and you know, most of them are horribly dangerous. Yeah. It's just a really bad idea to strap a jet to your back and fly through the air.
When I was a kid, a guy from NASA, I think, came out with a jetpack and gave a demonstration at the showgrounds, but actually I think he crashed.
Yeah, they're really impractical.
Also, science fiction can give a false sense of how science progresses.
And one of the things that always amazes me, say, on Star Trek, is they're having a big problem and they get the engineers together and they solve the problem within an hour, whereas in the real world, as a scientist, it can take decades and baby steps to make any major progress.
But perhaps one of the key benefits of sci-fi is it helps make the future seem more possible.
Like with The Martian, you know, you see this landscape, it's depicted as a place you can go, an achievable goal. And so I think a lot of times people see these kinds of depictions in science fiction, and that makes it seem more achievable, and it makes it seem like more of a goal that they can work toward.
And for Mars, that seems to be working. Inspired scientists and lay people alike are already planning to journey there. Australia has beautiful waterways, and fishing them is one of our favourite pastimes.
Ever since I was a kid, wherever I saw water, I thought I could fish. Maybe I was born with it, maybe it runs through the families. Just something about catching a fish is just kind of like a drug. Fish
is a healthy source of protein and omega-3 fatty acids. But is eating our fish safe?
Well, mercury can be a problem in the environment generally.
We have some of the worst levels of mercury worldwide in some of our hotspot areas.
It can then be transported into the food chains, eventually ended up in the fish, and those are the fish that we eat.
At very high concentrations, we can see some quite profound toxic effects on human beings.
But now, an exciting new invention might be able to help with the mercury problem.
When we exposed this material to mercury, it was a surprise. We realized at that moment that we had something that might be useful for removing mercury from water and soil.
The Derwent is a beautiful body of water, but there's a bit of a paradox there because the sediments in the system suffer from a legacy of metal contamination, particularly mercury.
Doctors Katrina McLeod and Hugh Jones have been studying the mercury levels in the Derwent River for many years.
In the hotspot areas within the system, the levels of mercury can be up to 10 times that of far more contaminated systems such as Tokyo Bay. The river and the estuary has sustained heavy industry for many, many years. So a lot of that is the legacy effect of those industries.
Mercury is a naturally occurring element. It's one of only 2 elements on the periodic table that's liquid at room temperature. It's beautiful, but also a potent neurotoxin.
At the bottom.
It is a heavy metal. In its natural form, it is a liquid as an absolute metal, but generally in the environment, you find it bound in various different forms.
One of the most toxic forms of mercury is methylmercury. It consists of 1 mercury atom bonded to 1 carbon and 3 hydrogen atoms, and it can be created as a byproduct of bacteria consuming mercury in sediments.
From the sediments, it can then be transported into the food chains, eventually ended up in the fish, and those are the fish that we eat.
Okay, so this is the sand flathead species. It doesn't move very much, so it gives us a very good indication of what mercury we have.
If we look at the bioaccumulation pathway, we can start at the bottom of the food chains, our little crabs that are eating the sediments at the bottom. They get eaten by a bigger fish, which then gets eaten by a bigger fish again that might be eaten by the shark at the top of the food chain. And as it travels up through that food chain, we see a biomagnification of the levels of mercury, the concentration of mercury up the food chain.
She's 260 mil, approximately 3 years old.
The Australian standards suggest that you shouldn't consume fish that have more than 0.5 milligrams per kilogram of mercury too often. In terms of the Derwent, then the black brim typically have levels higher than that, so the suggestion is don't eat them at all.
So definitely bottom feeding.
Methylmercury is one of the most toxic forms of mercury and one of the most commonly encountered forms of mercury that human beings will be exposed to. It can cause all sorts of neurological problems like shaking, memory loss, change in behaviour, numbness, lack of sensation, all those sorts of things, and ultimately at very high concentrations can cause death.
In Australia, severe mercury poisoning is extremely rare, but the legacy of contamination is widespread. Here in Port Botany in Sydney, fisherman Enzo Lisbona is at the top of the food chain, and he's casting off to catch his dinner.
I'd probably eat fish maybe 3-4 times a week, maybe more. That's fresh fish, and then canned tuna maybe 3-4 times a week on top of that. But I definitely love eating fish, especially fish that you've caught fresh. What I've heard about mercury levels in fish is that obviously too much is not good for you.
Dr. Simon Apte has been researching mercury contamination for almost 30 years.
We routinely test a variety of different specimens for mercury concentrations. We look at the total mercury concentration, and importantly, we also analyse the methylmercury concentrations.
Enzo's brought fish to Simon's lab for testing.
Went out fishing this morning and caught an Australian salmon for you.
Some he caught himself in Port Botany. Some he picked up at his local fish shop, both imported and local species. And cans of tuna, even some fish fingers.
I think it might be a good idea if we have a look at the mercury content of your hair as well, because that gives us an indication of how much mercury you're accumulating from your diet.
That'd be very interesting.
Human hair growth is quite variable, but typically of the order of 0.5 centimetre every couple of weeks. So one can imagine that if you take a 0.5 centimetre length of hair, that is a record of one's exposure to mercury potentially over the last couple of weeks.
Enzo will return in a week for his results. And they could be concerning, because his favourite fishing spot is a well-known problem area for mercury contamination.
Particularly in an area like Botany, we've seen mercury contamination in soils and in groundwater. And we've also seen mercury in waterways and also in biota of fish in the area. So we knew that mercury was a problem at source here, and what we did about that was a thorough investigation and then a thorough remediation project that involved removing the soils, it involved capping the remaining soil, and it involved putting in place a barrier going down into the groundwater to stop any groundwater migration off-site. And what that means is that over time we will see an improvement in those waterways, and over time we can see an improvement in any mercury levels in fish.
Like lead and other heavy metal pollutants, once mercury is released into the environment, it can sometimes spread great distances.
We certainly now understand that mercury can be a local issue, but it's a global issue as well. So emissions start off local, but they end up global. In some recent work we did with the CSIRO, we have found that most of the mercury that's emitted from Australian industry and domestic sources is transported beyond the shores of Australia.
It's estimated that of the world's 2,000 tonnes of man-made mercury emissions each year, a significant amount ends up being transported through the atmosphere all over the world.
We know that 100 tonnes is being transported to the Arctic. The estimate is that about half of that comes from atmospheric transport processes. So there is a recognition that there are hotspots for mercury issues in Australia. So the Derwent, for example, but we also know that this is a global issue.
On the Derwent, initiatives are underway to stop the emission process at the source.
So the Derwent Estuary Program is a collaboration between industry, councils and the state government. We test water quality every month for heavy metals, and we also sample heavy metals in the sediment once a decade on average.
One of the key collaborators in the Derwent Estuary Program is the Nyrstar zinc smelter.
We've been smelting zinc on the banks of the Derwent River for almost 100 years. We celebrate our centenary in 2017. Industrial practices in sites and operations like this haven't always been to the same standard that we operate at today. So for quite a lot of years now, we've been operating a program to address both the stormwater contamination and the groundwater contamination. For groundwater, we've installed a network of subsurface bores that extract contaminated groundwater out of the ground, preventing it from getting into the river. The stormwater program, we operate a completely closed drainage system. So when it rains, every drop of water that hits the ground gets captured on site in a range of detention basins that we've installed.
But there's another surprising project on the Derwent that's bringing science and creative brains together.
Mona started the heavy metal project because the Derwent Estuary is our home and we want to heal the river. We also care a lot about art and science, so it's really important for us to be able to bring together all of those elements.
Through a series of permanent art installations, one of Tasmania's most visited tourist attractions is bringing awareness to the plight of the Derwent Estuary.
The layers of rammed earth represent the sediments in the Derwent. There are 5 openings throughout the wall, and each one of those represents one of the main heavy metals found in the Derwent Estuary.
Other artworks are a door surrounded by mercury inside blown glass vials, and an oyster life raft, which includes Derwent River oysters attached to heart rate monitors.
We're hoping to get a snapshot of how healthy they are and how well they survive in an area close to Mona. The oyster mussoolia.
When we were first contacted about working with the Heavy Metals Project through Mona, and I think we were thinking it's a bit crazy idea here, you know. But the more we spoke to the group, the more intriguing it became.
I think one of the most unique things about heavy metal is the capacity for genuine collaboration. And we find between the science and art worlds this kind of unique amalgamation.
What it did make us do is look at a 70-year-old problem, a 100-year-old problem that we had seen as being insurmountable, turn the box around a little, look at it from somebody else's perspective and say, well, maybe it's not impossible. Maybe there's another way of looking at this.
While the collaboration between art and science continues, let's hear about that exciting new invention for dealing with mercury problems.
Hi there, Justin and Max from Flinders University in South Australia. We're excited for the opportunity to share with you some of our new technology. At the beginning of this research project, our initial goal was to make a new type of plastic from sustainable materials.
And that material was an abundant waste product, sulfur.
Sulfur is produced in more than 70 million tons per year. There is so much sulfur produced each year that it's incredibly cheap. They'll pay you to take it away. The first experiment using sulfur to make a polymer was a very simple one where we simply melted sulfur and it becomes polymeric. The problem is, after it cools down, this material is very brittle. It falls apart very easily. And so we had to go back to the drawing board and figure out a way to make polymeric sulfur, but a way in which it can stay as a polymer. To meet this challenge, we considered different molecules that could react with sulfur and hold it in a polymeric state. And one of them that struck our attention was one that's derived from plant sources, limonene. Limonene is the main component of orange oil. The citrus industry makes more than 70,000 tons of limonene per year, and it's used as a solvent, and you may have smelled it yourself in some cleaning products. At this stage in the research, mercury wasn't even on our radar, but it occurred to us, because our plastic has very high sulfur content, it should bind to certain types of metals. It's known that sulfur does have a high affinity for metals like mercury. And so the next experiment that was the logical progression in this research was to see how our sulfur limonene polysulfide interacted with mercury.
Along with student researcher Max Worthington, Justin set out to experiment and characterise the properties of the new polymer.
The first time we did this experiment, this was the setup. First, we took a sample of our polysulfide, and to it, we added a solution of mercury chloride. Mercury chloride is a type of inorganic mercury that's soluble in water.
So we apply the mercury chloride solution to the surface of the polysulfide, just a drop, and then we leave it for a while.
And after 30 minutes or a few hours, something interesting happens.
The mercury in the water seemed to be absorbed by Justin and Max's polymer.
So now if we remove this excess water with a pipette, we can actually see that the mercury left behind has turned the polymer yellow.
Typically, when we measure the amount of mercury left in this water, we find that 50% has been removed.
And this is a striking result.
So on discovering that the polysulfide could remove mercury from water, we thought to try a more complex solution. So we went on to try a soil sample spiked with mercury and found that, again, the polysulfide turned yellow. This result verified that it had been successful in removing mercury from the soil sample.
We anticipate that our material will also bind to methylmercury, but we haven't yet verified that in our laboratory. We have a polysulfide that can remove mercury from water, and as you work to remove heavy metals from the Derwent Estuary, we're hoping that this technology can be adapted to improve the environment. So hopefully in the near future, we'll see you down in Tasmania.
Wow, that was really interesting.
We have to get these guys to come down.
Yeah, I agree.
I agree. Justin and Max's invention still does have a lot of development ahead of it. Meanwhile, Enzo returns for his test results.
We have the results for your samples.
Oh, excellent. I'm a little bit nervous, but it's pretty excited at the same time.
OK, well, it should be some interesting news for you. Let's talk about the fish that you caught, the Australian salmon. So that contained 0.3 micrograms per gram of mercury.
OK.
The current guideline value for that sort of fish is around about 0.5 micrograms per gram, so the concentration of mercury is lower.
So we're doing all right?
Yep.
Large predators, which are high on the food chain, like swordfish, should be consumed in moderation, particularly by pregnant women. Fish that live a long time and so have many years to accumulate mercury, like ocean perch, also had elevated mercury levels. Because the tuna put into cans is typically smaller, canned tuna had some of the lowest mercury levels, as did the fish fingers.
I did a few calculations, and a person of your size can consume about 120 fish fingers in a week.
Oh, wow, so a fair few.
And similar with tuna, you can probably eat about 40 cans a week.
Excellent,
before
cool.
your mercury burden becomes a problem. So that's all good news. OK, now on to your hair sample, Enzo. That was interesting. Your hair contains 1.7 micrograms per gram of mercury.
So now is that high, low?
It's actually low.
Oh, wow.
Yeah.
Awesome.
For people who eat a lot of fish, we can sort of see concentrations of above 20 micrograms per gram.
Oh, excellent. So it's quite low, actually.
Yeah, you're way lower
Awesome.
than that.
Gives me a licence to eat more fish.
Pretty much, yeah.
Excellent. Thank you.
I think Enzo's doing the right thing. He's obviously making the right choices in terms of the fish that he eats. So the general message to everybody is just make sure that certain fish like swordfish and shark are consumed in moderation and everything's fine.
I'll definitely keep fishing. They taste too good to stop eating. As long as my heart's beating and I haven't dropped dead, I'll just keep eating fish.
For more information on fish and mercury, visit the Catalyst website. The power of music to awaken the brain.
Somehow it's like a side door into the brain, and it just means that they can come alive for that moment. And when those memories come flooding back, it's connecting them with identity again.
So what we do is called entrainment. Our brains pick up on that beat instantly, and then we hold it in mind so that we have the beat going in our mind, and then we are able to synchronize our movements to that beat.